Clocks settle to universal time. Lenses clear, cables cool, and the array takes its first disciplined breath. On October 29, the question is narrow. If a non-natural target crosses the field, what trace will it leave in light, heat, and radio, and will that trace survive independent checks? Baselines across stations are fixed and verified. Beacon loops confirm microsecond timing. The decisive bar is simple and hard. Signal to noise above the pre-declared floor, coincidence in more than one instrument, and calibration residuals inside tolerance. No drama, only an auditable path from photon to inference. Each channel has a role. Wide field optics, sketch motion against a cage of reference stars. Near infrared tests for warmth out of proportion to size. Radio listens for narrow lines or structured drift that careless engineering might leak. Timing turns parallax from wish into range, keeping near-field illusions out of the ledger. The window cooperates. Winds are steady, the ionosphere calm, civil traffic sparse. 3i, instrumentation, isolation, inference shapes the posture. Atlas stacks evidence rather than anecdotes. Any candidate must climb, layer by layer. Appearance, corroboration, distance, model, fit. For the span of this watch, the promise is not spectacle, but clarity. Noise will be pared away, artifacts will be flipped and dismissed, and what remains will either reach the decisive threshold or fold back into background. October 29 is not an omen, it is a test, and the instruments are ready to grade. October 29 was chosen for geometry, not theater. The target sector tracks a high, quiet arc that keeps bright guide stars in frame and avoids meridian flips that fracture calibration. Forecasts aligned, stable upper-level winds, a low KP index, and a tame total electron content, all of it easing the smear that long baselines suffer. Civil air corridors, thin during the window, trimming the garden variety clutter that can masquerade as intent. Under 3i, instrumentation goes first. Each site locks its clocks to a disciplined reference and proves it with round-trip beacons. Offset and jitter are written to the header, not guessed. Wide field optics are plate solved on standard fields to pin plate scale and distortion. Infrared imagers run temperature-matched darks and flats to map drift and hot pixels. Radio front ends sweep known beacons to anchor gain, noise figure, and usable dynamic range. Those numbers later define what emergence means. Isolation is a policy, not an afterthought. Satellite ephemerides and TLEs seed the first mask. ADS-B and MLAT feeds fence-off aircraft. Meteor and lightning networks flag transient skies. Local quirks get their own profiles. Sodium lamp insect blooms, rooftop thermal plumes, cable flutter that writes diagonal scars. Anything the world already understands is subtracted early, not to banish anomalies, but to keep them from drowning in the familiar. The rule is blunt. Explain the explainable before elevating the unaccounted. Inference waits at the end of the pipe. Likelihood ratios adjudicate between natural, human, and artifact stories for the same pixels and samples. Priors are conservative and documented. Stacking across channels only occurs when measurements are independent and reproducible. A light-only event that dies in heat is demoted, while a candidate that coheres across timing, optics, and radio climbs a rung toward decisive. Observability has ceilings, and they're owned in advance. Angular resolution limits fast movers. Short exposures lift cadence but tax dynamic range. IR reach fades with small cold targets. RF localization blurs when geometry is shallow or ground echoes intrude. Parallax baselines are strong enough to bound range but too short to draw a full orbit in one pass. Those limits are modeled so a later no becomes a quantitative contour, not a shrug. Finally, custody makes the data answerable. Raw frames carry hash timestamps and calibration metadata. Every hop to archive is checksummed. Blinded clips are injected during the run. If the pipeline misses one, confidence is reset before claims proceed. With that scaffolding in place, the window is not simply open, it is measurable, repeatable, and prepared to turn either signal or silence into information. The window opened because forecasts converged, not because appetite grew. 2 weeks out, models predicted a lull in geomagnetic agitation and a thinning of ionospheric structure, both friendly to long baselines. Seeing charts promised steady layers, and civil traffic maps showed a trough across the target corridor during the intended hours. On the planning board, these curves, TEC, KP, seeing corridor density overlap to form a narrow plateau. That plateau was the ignition, a span long enough and quiet enough to let measurement set the tempo. A prior hint shaped the question. Earlier runs had logged short, uneven tracks that resisted satellite catalogs yet carried no infrared warmth proportional to their apparent size. Timing slack and single station coverage kept them below the bar, but they traced a silhouette. If a genuine candidate returned, it would likely live where light suggested mass while heat did not, and where motion pressed against but did not mimic cataloged patterns. October 29 was chosen to ask that question again with tighter clocks, cleaner parallax, and a wider spectral net. Objectives were stated in numbers. M1, spectral and kinematic discrimination. Wide field optics and near-infrared would co-record any track while radio fronts watched adjacent bands for narrow lines or structured drift. The target was a bundle, not a streak. Light curve behavior, color temperature, and any RF glide that careless engineering might leak. Acceptance required signal to noise above the declared floor in at least 2 independent channels, with calibration residuals inside tolerance tested earlier that night. M2, range and scale via parallax. Geometry would downgrade guesswork. With baselines spanning tens to hundreds of kilometers, simultaneous frames could bound distance rather than infer it from size or brightness. Near-field artifacts, thermal sparkles, insects, cable glare should collapse under parallax. Distant objects should shift with disciplined subtlety. Success meant coincident detections from a minimum of 2 stations, beacon-verified timing, and a parallax solution whose uncertainty beat the pre-run bound. M3, motion model testing. Tracks would be fitted against straight-line inertial, ballistic, orbital, and control-like profiles. Acceleration and jerk would be compared to what instruments and atmosphere can forge. A preferred model had to emerge by information criteria, not preference, and residuals had to live inside the validated noise model. If orbital explanations won cleanly when TLEs were broadened to account for catalog staleness, the candidate would fall toward the prosaic. Safeguards were locked in before data arrived. The team pre-registered thresholds, vetoes, blind inserts, and failure modes. Any signal living in a single channel would be demoted. Any detection that flipped sign under parity tests or evaporated when calibration order was shuffled would be discarded. Short cadence recurrence would raise confidence. Uniqueness without corroboration would not. Contingencies were spelled out. If clouds clipped a station, clear sights would assume timing primacy while RF increased dwell to compensate for optical loss. If a clock slipped, its stream would be quarantined, not massaged. If civil traffic spiked, ephemeris and ADS-B masks would tighten in real time, accepting false negatives over contaminated positives. The aim was not to nurse borderline cases across the line, but to keep the line fixed. Ignition then was a lattice. Environment quiet, baselines tuned, priors restrained, criteria public, and objectives pinned to metrics with teeth. October 29 was not a promise of surprise. It was a commitment that should surprise arrive, it would meet instruments ready to grade it. The night opens on a calibrated sky. Aperture fixed at f 2.8, exposures at 40 milliseconds, gain set by a standard star sequence to keep scintillation under 5%. The first frames rebuild the plate. Astrometric solve locks plate scale and field distortion. A polynomial warp flattens the corners. Known satellites trace predicted arcs and are labeled from live ephemerides. Civil aircraft register as steady vectors cross-checked against ADS-B. Hot pixel maps and column bias models prune sensor ghosts. Wind metrics suppress frames whose shake exceeds the pre-declared tolerance. For half an hour, everything conforms to forecast useful silence. At minute 32, a short, dim trail cuts the upper field. Its angular speed skews toward low Earth norms, yet its light curve is unusually flat for a slow tumbler. Single camera only, 10 frames long, signal to noise, clears the floor. The pipeline assigns 01 weak, present, but one-eyed and brief. The thermal channel rides the same patch with slower cadence to deepen temperature reach. Before acquisition, the imager cycles temperature-matched darks and flats. The hot pixel atlas refreshes on the hour. The purpose is narrow. If O1 is a body of non-trivial size moving quickly, its heat should betray it even when reflected light is shy. Rooftop plumes write familiar swells. Insects and birds read as pulsed micro-signatures near sodium lamps. During O1's interval, the IR field is quiet, no coincident warmth above the model threshold for a decimeter-class target across the plausible range band. Two narratives remain: a near-field optical glint too small to heat, or a distant cold reflector. Either weakens the case for a conventional warm airframe. Status nudges to O1, moderate pending parallax. Optical and IR agree on what they do not see, but distance is unpinned. Radio front ends carve the spectrum into clean subbands, each guarded by a beacon to monitor gain and clock integrity. A pre-window survey set the ambient drift from ionospheric structure and local emitters. During O1's timestamp, the bands are calmer than median. No slanted line with Doppler consistent with a co-moving transmitter appears. At minute 45, a narrow, low SNR tone surfaces for 12 seconds in a sideband, drifting linearly. With no optical companion and geometry compatible with a ground echo, it is labeled R1 weak. Beacons behave, timing holds. RF neither corroborates nor falsifies O1. The stacking rule stays firm. Without an independent axis, promotion is paused. Here, the test sharpens. GPS discipline oscillators keep all sites on the same second. Round-trip beacons quantify microsecond residuals. Frames containing O1 are pulled from two stations over 100 kilometers apart. Site A has the track. Site B's field edge is brushed by a transient cloud bank. Without a clean B detection, parallax degenerates. Near-field hypotheses cannot be dismissed. Per pre-registration, single-station candidates lacking a second eye are held rather than argued over. O1 returns to weak hold. The cloud mask, however, stores water vapor intensity and sky brightness, allowing a quantified misprobability rather than hand-waving silence gains a likelihood, not a shrug. All tracks longer than a few frames, O1 included, run through competing kinematics: straight line inertial, ballistic deceleration, orbital pass with catalog slack, and control-like splines constrained by jerk limits. O1's brevity and missing parallax keep information criteria agnostic. No model earns preference. Later, a cleaner trail, O2 crosses midfield, with high SNR, intersecting several reference stars. When ephemerides are expanded to accommodate a stale TLE, an old satellite becomes a strong fit, and residuals drop into the noise. O2 is not the quarry, but it proves the pipeline converges to mundane answers when data are sufficient, a needed control. Interleaved with the passes, the system runs flip tests, reverses sensor readout parity, shuffles frame order, and injects a few blinded calibration clips mimicking benign variables. The pipeline catches the inserts and demotes a would-be candidate, O3, that disappears under parity reversal, a textbook column read artifact. O3 is excised and logged with a corrective note for firmware settings. These intrusions are not distractions. They are health checks that keep enthusiasm from carrying a weak signal uphill. As the night warms, the western roof emits a thermal plume that IR maps in steady gradients. Wind sensors show a correlated rise. The optical channel exhibits periodic microstreaks whose orientation matches the vibration vector. A cross-correlation between accelerometer logs and streak direction yields a high coefficient. The classifier stamps mechanical flutter on the family and pushes them into background. A brief insect bloom around sodium lamps paints the lower field. Fused IR optical features, wing beat cadence, spectral profile, sort them into near-field bins. The aim is not to erase complexity, but to make complexity legible so that a real outlier is not built on a bed of mislabeled noise. At 017 UTC, a thin, steady track appears near field center. SNR is comfortably above threshold. The light curve is flatter than a typical tumbling reflector. Near IR remains quiet. Radio shows no contemporaneous line. This time, site B is clear. A faint companion trail is present at the same timestamps. Parallax resolves with bounded error, placing the object a few hundred kilometers out, compatible with low Earth altitudes. When ephemerides are broadened to include uncatalogued debris windows and age-biased TLEs, an unresponsive orbital object becomes plausible. Motion fits prefer an orbital model. Residuals shrink when drag and phase angle are allowed to vary. O4 is labeled moderate natural leaning, promoted by two-station optics and parallax, tempered by the lack of RF or thermal signature, and by a serviceable orbital explanation. Two faint, fast glints flirt with promotion but fail repeatability on short cadence. One repeats at a period synced to a known wind-induced resonance in a nearby mast. The other vanishes when the cloud mask threshold is tightened, indicating marginal transparency rather than motion. A weak RF whistle correlates with a distant rail crossing. Antenna patterns and bearings favor a ground path. Each case earns a clear tag and is routed out of the stack. The goal is to leave as little unknown as possible in the wake, so that the surviving unknowns are truly thin. Stacking is not a vote tally, it is a battery of orthogonal questions. Is it there? Optics. Is it warm? R. Does it talk? RF. How far? How does it move? Model fit. Advancement requires coherence across questions that do not share failure modes. In this window, the strongest answers converge on prosaic dynamics, where geometry is good, where channels disagree or go silent. The silence becomes a bound rather than a lyrical maybe. The October 29 sequence did not crown a heavyweight anomaly. It demonstrated that the pipeline rejects artifacts when parity flips, fits orbit when ephemerides catch up, quantifies misses when clouds intrude, and refuses to elevate single-channel curiosities. O1 teaches the risk of one eye. O2 shows correct convergence. O3 validates the guardrails. O4 illustrates how two independent eyes plus a workable motion model can explain much without invoking the exotic. The anomaly stack, therefore, is less a scoreboard than a contract. Any future claimant must survive independent axes, pre-declared thresholds, and calibrated skepticism before the label decisive leaves the page. Silence is not a blank. It is a boundary with numbers. No narrowband line rose above the radio floor. No infrared bloom cleared the modeled threshold, and no optical trail survived every sieve with parallax and fit in hand. That absence does not say there was nothing. It says, under October 29 conditions, any source in the watched bands radiated below the derived ceiling, any warm body larger than the IR reached at the solved ranges, heated less than our optics could see. Any fast reflector brighter than the limiting magnitude at our cadence did not cross the field. Those ceilings are the night's yield. RF dwell, bandwidth, and measured noise figure translate into an upper bound on equivalent isotropic radiated power for plausible drifts. Below that line, a transmitter could whisper unheard. IR sensitivity curves, paired with parallax-capable sequences, become limits on thermoluminosity versus size and distance. Optical limiting magnitude, exposure, and cadence set constraints on cross-section, albedo, and angular speed. Each node turns into a contour on a parameter map, shrinking the space where speculative models can live without contradiction. Silence also calibrates belief. Priors tilt away from emission-heavy explanations and toward passive or absent ones, modestly, not melodramatically. A meter-class warm target sweeping low Earth altitudes contradicts the IR bound. A drifting carrier commensurate with co-motion through our bands would have tripped the RF floor if present. Since it did not, either it was off elsewhere or too faint. Bayesian updates are logged, not asserted, so that future windows start from a documented posture rather than memory. The null audits the pipeline. Blinded inserts were caught, parity flips demoted artifacts, and cloud masks quantified missed opportunities. Power analysis turns quiet into a sensitivity statement. For classes A and B, bright reflectors, modest thermal sources, detection power was high. For class C, small, cold, low albedo bodies, it was thin. That discrimination guides upgrades, not headlines. Design follows from the silence. More mid-baseline stations to rescue parallax when one eye clouds. Slightly wider RF sweep with improved localization to peel ground echoes from skylines. Faster optics or carefully culled longer IR integrations under stricter sky cuts. Real-time QC to downweight shaky frames before they can contaminate a stack. Finally, the null is publishable. Raw clips, calibration sets, QC outcomes, and sensitivity curves will be archived with DOIs so others can rerun the argument and avoid rehunting already excluded phantoms. October 29 speaks by subtraction. It defines where a signal was not, and by doing so, it sharpens where the next one must be to count. The October 29 window ends with a measured verdict. No candidate cleared the decisive bar with independent support across optics, infrared, and radio while meeting pre-registered timing and parallax requirements. The strongest case, 04, settled cleanly under orbital dynamics. Once range and motion were constrained, the remainder either failed parity checks, fell into weather-driven ambiguity, or never stacked beyond a single channel. Provisional resolution. Within the achieved sensitivity, the data favor ordinary, natural sources. Nothing compels an artificial origin claim. That stance is earned, not hedged. Pre-annotation fenced bias. Blind inserts policed vigilance. Stacking rules prevented enthusiasm from promoting a one-eyed curiosity. Where a track survived one axis, another asked a different question: distance, heat, spectrum, kinematics, and coherence thinned. The apparatus kept its promise. Convert impressions into likelihoods. Let independent instruments arbitrate, and keep only what remains when shortcuts are removed. Costs were counted in hardware, bandwidth, and time. Multi-station telescope hours were diverted from guaranteed programs. Infrared sensors ran aggressive cycles that shortened maintenance intervals. Radio front ends reserved quiet subbands, trading breadth for stability. Storage grew quickly because raw frames, calibration sets, and audit logs were archived without lossy compression. Reproducibility took precedence over convenience. Human costs showed up as split shifts, double coding for redundancy, and slower review dictated by chain of custody. Opportunity costs shadowed the run. The window overlapped minor but valuable targets for partner projects. They yielded slots on the condition that nulls would be published with the same care as detections. That pact is part of the price of rigor, a result that is not headline-shaped but still consumes premium conditions and attention. The return is methodological, clearer bounds and a tighter pipeline rather than theatrical. Risk sat inside the methods and was handled there. Timing could drift. Beacon round trips kept clocks honest. Mechanical flutter could write false streaks, accelerometers, and shake metrics linked pattern to cause and demoted bad frames. RF could be fooled by ground echoes. Geometry, antenna patterns, and bearings narrowed the plausible. The most stubborn failure mode single station temptation was neutralized by policy without parallax or an equally strong surrogate for range. A candidate is an anecdote, not evidence. Where clouds blinded a second eye, the data were quarantined, not massaged into compliance. What would reverse this provisional stance? Category A evidence would be a replicated parallax solved track co-detected in at least two spectral neighborhoods, optical plus IR or RF, with calibration residuals inside the declared box, and a motion model that penalizes orbital explanations by information criteria. Category B would be a narrowband line with non-terrestrial drift persisting across antennas and nights, co-timed with an optical track that resists ephemeris fits when catalogs are broadened for staleness. Category C would be recurrence, the same sector reproducing an out-of-family signature over multiple windows, forcing priors away from coincidence. The window also writes an upgrade list. Parallax failed most often for lack of a mid-baseline partner under Apache Cloud. Adding portable, disciplined mid-range stations is the clearest leverage point. Optical cadence can rise modestly if readout paths are retuned to avoid column artifacts, clawing back sensitivity to faint, fast movers. Infrared reach needs either faster optics or longer, tightly culled integrations paired with stricter sky cuts. RF warrants a wider sweep with improved localization to peel rail and roadway echoes from skyborne lines. Across the stack, a lightweight real-time QC agent should demote frames that vibrate, clip, or miss timestamp before they poison a candidate's ledger. Accounting is not complete without ethics and transparency. Open negative results are not charity. They are the mechanism by which the field stops chasing ghosts. The team will release raw clips, calibration files, QC decisions, and sensitivity curves with DOIs so outside groups can rerun the arguments. Claims will be framed as bounds and likelihood ratios, not identities. Where the pipeline failed a blind insert or exposed a firmware quirk, the record will include the fault and the fix. Yesterday's weakness becomes tomorrow's guardrail. In summary, October 29 closes on discipline. The night did not produce a multi-channel anomaly. It produced constraints, an audited absence, and a cleaner method. If something extraordinary crossed the field, it remained below the thresholds this array could impose. That is not failure. It is the floor on which any stronger claim must stand and the baseline the next window will attempt to raise.